So on our lesson 3.5 today, it's the main topic of it is working with scatter plots. And on scatter plots, we can also draw trend lines. And that's something you should be pretty familiar with both now after SP3R in the lesson. Okay, our first vocab word. A graph of points plotted to show a possible relationship between two sets of data. What's that called, Ashton?
A scatter plot.
That's a scatter plot. Okay, a scatter plot. When you want to show the relationship between two sets of data, you can assign one of them to be the independent variable, the other one to be the dependent variable, one of them on the horizontal axis, the other one on the vertical, set up some ordered pairs, and graph the points. Okay, now scatter plots are useful for some things, but not always. What's true about scatter plots? What did you discover in your reading and doing practice problems in your notebooks? What did you discover about scatter plots that maybe hasn't necessarily been true about the other graphing we've done in this particular chapter? Or maybe first of all, we should decide, are they discrete or are they continuous graphs?
Discrete.
They're discrete, aren't they? Okay. Well, when they're some of our discrete graphs, they've had patterns to them, haven't they? They're like the points are going in a linear pattern, or they're maybe in a V, or they're maybe in a U-shaped graph. But on a scatter plot, is there really any sort of a distinct pattern going on necessarily? No, not really. Okay, so scatter plots are just kind of like you have these points on the graph, and you're just going to try and decide, if they have a relationship to each other or not, and then what kind of relationship do they have. So here's one of them that you actually had to do in your notes, but let's see how you did. We'll redo it, okay? First thing you have to decide when you're going to make a scatter plot is which one's going to be the x's, which one's going to be the y's. So what did you assign the x's? The game?
Yeah.
Or the number of points scored?
Game.
Game. Hopefully you decided that that would be a good one because what is x? Remember, the x controls the situation, right? And so wouldn't the game that they played in control how many points was scored in that particular game?
Yeah.
It's kind of like not because it was game 4, that tells us that's how many points you're going to score, but because it was game 4, we know as a result this is how many points they scored. So we have how many ordered pairs here, really?
4.
We have 4 ordered pairs. What's one of them?
1, 6.
1, 6, and then we have 3 others, right? Okay, well, when you make a scatter plot, you and anybody else who looks at your graph should be able to very easily tell what that graph is about without having the table or any other information. So the first thing we want to do is we want to give this scatter plot a title. What's this data about? Where does it come from? A football team. This is about the football team. And we decided that the x-axis is going to represent the game, and the y-axis is going to represent the score of that game. So we first have to title it. We need to assign the variables to which of the 2 data sets is going to be the x's, which ones are going to be the y's. Put those titles on the axes. Then the next decision you have to make is what kind of a scale should I use on those axes? So what are we going to use on the x-axis?
6.
Should we go by 6s on the x-axis for games?
Oh, no. That's it.
Can we just go by 1s?
Yeah.
Yeah, it's 1, 2, 3, and 4. Couldn't we just let each grid line represent 1 unit or 1 game, right? Well, how about on the y-axis? What did you go by?
6.
6 is like, even though it starts at 6, that doesn't necessarily mean that's what we should make our scale. Sometimes we want to make our scale something that's like a lot easier to label than going by 6s. And I heard 5. That's probably what I would choose. Let's do by 5s. And you don't have to label every grid line, do you? But every grid line has to represent, between grid lines, it has to be 5 points. So 5 for the first grid line. I'm going to skip over the second one, which would be 10. Third one would be 15. Skip over. So in reality, I'm labeling every 10. And lots of lazy people on the quiz, not labeling the axes on the graph. Get this labeled. On your scatter plots, if I don't see these guys labeled, these axes labeled, I'm going to take points off. Because it's really hard to read a graph without those labels on it. Now we're going to graph our ordered pairs. We have it set up, we have a good setup. Now when somebody looks at our graph and sees our ordered pairs, they're going to make sense to them. Okay, so ordered pair 1, 6, you want to make sure that you pick a good location for it. These axes are like number lines. Logan, work with us. Ordered pair 221, 346, and 434. They got to be in good locations. You got every point on the y-axis is really a fifth of a way between one point is 1/5, 2 points is 2/5 of the way between grid lines. So is that how yours looks in your notes, something like that? Okay. Does it look like, you know, there's a relationship here that
No.
the game that they were in really have anything to do with how many points were scored?
No.
Did you see any sort of, I don't know, kind of looks to me like as you move across the graph, aren't the points getting higher, at least for a while? And then it drops down 1. So, but this isn't a whole lot of data to help us make too much of a decision. If we had maybe the next 4 games, then we might be able to say, oh, okay, it appears that they got better as the year went on. Here we don't know. Maybe it was just they played a really good team the first game, and then they played a really bad team in the 3rd game, right? Okay, so what's this vocab word? Describes a relationship between 2 data sets. What's going on there? What's that? Ashton?
Correlation.
Correlation. Is there any correlation between the data? Does one really affect the other, does it seem like? Does it look like? It doesn't mean that there's a difference between cause and effect and correlation. So we have to make sure that we just what we're doing is we're just taking this one data set and saying, does it look like there's a correlation between the 2 things?
No.
So in this one, you're saying no, the one that we already have there? Okay. Somebody else might argue it looks like there is. But there are 3 types of correlation. What are they? When both sets of data increase, so as the x values get higher, so do the y values. What's that, Jonathan?
Positive.
Positive correlation. As one increases, so does the other. And so the points, when there's positive correlation, there's a grouping of the points kind of going in what general direction? Rana? They're heading up as you go from left to right, aren't they? They're climbing as you go from left to right across the graph. Well, what if one of them's increasing and the other one's decreasing? That's negative correlation. When one's going up and the other one's going down, there's a negative correlation. Well, does there have to be correlation at all?
No.
No. When there's no relationship between the data sets, what's a no correlation graph look like?
Just scattered.
They're scattered all over. They're so scattered all over you can't really see any sort of a pattern going on. It's just like somebody took a pencil and just kept stabbing it everywhere, right? So no correlation. There can be a data set where there's no correlation going on whatsoever. Sometimes it's hard to decide if there's correlation or how strong it is. And next week when we start using graphing calculators with this and putting a trend line in it, we'll be able to tell, the graphing calculator can calculate what's called an R value that shows us the strength of the correlation. Okay, so and let's describe the correlation for this one here. What's this scatter plot about? What's that scatter plot about? You should be able to look at it right away and say, okay, it's about Hunter. Beach visitors, the title of the graph. It's about beach visitors. What's it comparing? What are the 2 data sets? What is it comparing, Ricky?
Visitors by average daily temperature.
Okay, it's saying when they took the average daily temperature in degrees Fahrenheit and said, okay, well, here's what the temperature was. How many visitors were there at the beach on that particular when that temperature was at that particular mark? So, right now, do you think it looks like there's some correlation between the two? Now you gotta remember, guys, they're not gonna line up in a linear pattern. They're not gonna be all on straight on a line. They don't all have to be one, that you could draw a ruler through them all to take it, and use a ruler and it has a straight edge and draw a line through them all. That doesn't mean correlation. Correlation means is there a grouping of the points and some sort of a pattern in that grouping going on. So let's look at this. As the average daily temperature increases, let's move across the graph from left to right.
But
As
it
the,
doesn't always increase though.
okay, but let's just look. As the average daily temperature increases, as we're moving across the graph, what's happening to the visitors in general? It's going up, isn't it? Aren't the points getting higher? So we could really say in this case that there is correlation because it appears, doesn't have to happen every single ordered pair. But in general, as you're going across that graph, as the temperature goes up, so do the number of visitors go up. So we would say there's what kind of correlation? Positive correlation. We don't know how strong that correlation is right now, but we know it looks like there's some positive correlation between these two. Jonathan?
But it looks to me like it is pretty close to the same number of visitors when it's 82 degrees and 80, in between the 86 and 88.
So what would that be, 87?
Yeah.
Okay, so when it's 82 degrees and 87 degrees, it looks like there's about the same number of visitors?
Yeah.
Yeah, that's okay.
But then it doesn't always increase though, so how can you?
It doesn't always have to. On a scattered plot, it doesn't, every point does not have to.
Oh.
In general, you say, okay? In general, as the temperature gets higher, the number of visitors is higher. Yeah, we can single out this one point here and say, you know what, you kind of look like a reject. But that's okay, you can have a reject in a scatter plot. We call them outliers actually, not rejects. Okay, so, but that's a good point. How do we know? Well, in general, as we go across the graph, the points are getting higher, aren't they? Okay, any other concerns or questions? Okay, then let's move on to identifying correlation. Here we don't have any graphs. Let's just see if we can do it without a graph. Identify the correlation you would expect to see between a pair of data sets. So in other words, is it positive correlation, negative correlation, or no correlation? And then explain. In other words, why do you say that? So the average temperature in a city and the number of speeding tickets given in that city. Think there's any correlation? Yeah? No? Why not?
Because the two relationships, yeah, they don't even make sense. The average temperature and the spending tickets.
Yeah. So how would we say that if they don't make sense? Is the average temperature going to affect? Yeah, we're going to say no correlation. That's going to be our answer for what type of correlation. But then we're going to say there's no correlation because why?
They have nothing.
Because nothing really.
They don't really. Yeah. One isn't really going to affect the other. No correlation because temperature should not affect the number of speeding tickets.
And somebody could just have a big one foot and just speed every single day.
That's right. We might be able to find a correlation, like speeding tickets and what? Between number of speeding tickets and what? Number of cars on the road. There might be a correlation. The more cars are on the road, the more speeding tickets. The age of the driver?
Oops.
Maybe. We don't know. You have to collect some data and find out. But chances are, if we collected data and measured the temperature outside, and measured how many speeding tickets and collected about 20 different times, chances are their probably points would be all over the graph, wouldn't they? There'd be no correlation. Okay, there's one more on the back side here. A runner's time and the distance to the finish line. Any correlation between a runner's time and the distance to the finish line? What do you think, Ashton?
That it would be a positive.
A positive correlation. Because what?
Because even though that he might be getting slower by the time, like the timing, the timing is.
Okay, now remember, positive correlation means what?
Rises.
As one increases, so does the other. So as the time increases, is the runner's distance going to increase? No.
It's gonna decrease because he's
Not
gonna
the
shorten distance to
It
get
says
there.
it doesn't say distance run, it says distance to the finish line, doesn't it? So let's, in fact, let's make a little picture of this one. Time would be here, and I'm just gonna call it D left. Isn't that what it would be, distance to the finish line? How much distance is left? So you start out, you're gonna run a 200-meter race, and after you've run for a little bit, so time has gone on, and after you've run for a little bit, are you going to have most of the distance left or just a little bit of the distance left? After you've just run for a little bit, 200 meters. That's halfway around a track. You've taken off, you've run for a couple of seconds.
Less.
You have less distance, but are you going to have about 180 meters left, or are you going to be down to about 20 meters?
Probably 180.
Probably 180. And then after a couple more seconds, are you going to be, is it going to be 170, 160 meters, or is it going to be 40 meters? In other words, is the meters going to keep increasing, or are the meters going to keep decreasing?
Decrease.
They should decrease, shouldn't they? So the point should look like this. You start out, you have this much, and then after, so you should have, it should really be going down until you reach the finish line, shouldn't it? So you got to be really careful that when you read it, distance to the finish line. So you're getting closer to the finish line as you run, aren't you? So we would say this has what kind of correlation? Negative correlation. Negative correlation because the more time spent running, that's talking about the time increasing, the more time spent running, the less distance left to cover, right? It should be going down. So as the time is increasing, the amount of distance you have left to run should be decreasing. Thank goodness you never run, you never reach the finish line, huh? Negative, oh here, so I just wrote that kind of, okay, here's where my sentence starts right here. The more time spent running, the less distance left to cover. I didn't do because in there, so I'm going to say negative correlation, that's a phrase, then I'm going to start my sentence. The more time spent running, the less distance left to cover. You need to make sense when you're explaining these. You need to write in sentence form, capital letters, punctuation. Somebody better be able to understand what you're talking about. You don't get to just say, because it works that way. That wouldn't be a very good explanation. Anybody have questions on that? We don't have a graph. We can make our own if we need to help us, but we don't have to. We can do it without it. Okay, then we're going to move on to choosing the scatter plot that best represents the relationship going on here between the age of a car and the amount of money spent each year on repairs, and explain. So, which of those graphs would best represent that relationship? We got the age of the car, how old it is. So the older it gets, what should happen to how much money total you're going to spend on repairs? What do you think? What kind of is, first of all, what kind of correlation do you think we should be looking for, positive or negative?
Positive.
Positive. You're thinking that the older the car is, the more money you'll spend on repairs?
Yes.
That's really probably what should typically happen, yeah. The newer it is, you better not be heading into the car garage all the time, yeah.
Depends if it's a brand new car just made or it's
it still really matters that the older it gets, the more miles that are getting put on it, and the more the parts are starting to wear, aren't they?
Yeah.
Yeah, that's really typical. So as it ages, as the age increases, probably so do the repair costs. So we gotta look for a positive correlation, don't we? Well, we get two of those that have positive correlation going on in there. So do you want A? Or B?
No, because a car can't see it.
Look at that, look over here. Can we have negative?
No, you can't have negative.
No, we gotta throw that one out. That one's gone. Can't have negative. Time. So, looks like we're gonna go with graph B. And graph B, we're going to, after we say that it's going to be graph B, what's our explanation for it? The older the car,
The more you pay.
the more you repair it, right? Isn't that typically what happens? The older the car, the more you have repairs.
Not necessarily, I mean,
I know, I get that some cars maybe not, it depends on how many miles they're on. And that's the one thing that's really about scatter plots, we do a lot of what ifing, okay? So we don't say what if it's a Chrysler. Or what if my grandpa has one and he just keeps it parked in the garage all the time, he never has to repair it.
Then he's gonna have to repair it.
Average
I have a 30-some-year-old pickup. And all I have to do is fix those carburetor, I believe, in the engine. And
Only in our carburetor and an engine, huh?
yeah, that's it. Just the carburetor. That's not that hard to fix.
Still repairs.
It's still a repair, isn't it?
Costs $20.
It's
Okay,
$200, and that's all I have to do to it, though.
okay, so again,
And it's 30
this
years
is
old.
Jonathan, he thinks his one vehicle, this is not true for it, so does it have to hold true for every vehicle? No, in general, right? So, again, we like to come up with scenarios and say, but no, I can prove that wrong.
There you go.
Because there is that point or two that we call what? Rejects? No.
Yeah, rejects.
Outliers. Maybe yours is an
Rejects.
outlier, huh? So in general, the older the car, the more you have repairs. So we have a positive correlation going on there. Okay. And I know, but it's going to be really hard for me to assess you on this if you're doing your, but what if things, okay? So, okay, what's the next vocab word? A line on a scatter plot that helps show the correlation between the data sets more clearly is called a trend line. Now that is not a line that has fashion. That's not what that means, right? Okay, so what we do is we draw a line going through the data points, and if it has a fairly good correlation, those data points should cluster pretty close to it. It should be almost like, it should kind of look like it's a magnet, like it's kind of pulling them towards it. But if that line's just going through and they're kind of all over the place, those points, that trend line is worthless because that means it was a graph that probably didn't even have any correlation, so then a trend line isn't even needed. Well, if we think there is some correlation going on in the graph, we can draw a trend line, as in this one. What's this one about without even reading the paragraph? Just look at the graph. What's it about? Concession stand sales. Well, we don't know where we're at though, but we do know that at this concession stand sales, wherever this is, they're doing what? Comparing what to what? Yeah, tickets sold to sales that they made in their concessions, right? Okay, well this happens to be at what? What does it say up in the reading? At a movie theater. They probably could have added that there, right? Movie theater concession, and then we wouldn't have even had to read that. Okay. Well, it says what we do with trend lines, why they're so handy is we can make predictions with them. We say, according to this data that was collected, if this trend continued, we could count on we could just make some predictions based on this. So they wanted to predict how much money would be collected when 150 tickets were sold. And so they said, draw the line that has about the same number of points above and below it. So when you draw your trend line, you have to learn how it's, you get better at it the more you do it. Your line may or may not go through the points. It might go through some of them. It might not go through any of them. It might go through all of them. It does not have to go through any or all of them, okay? A trend line goes through the middle of the points, what you think looks like about the middle of them. So then it says find a point in the line whose x value is 150, because that's how many tickets were sold. So what's the scale being used here on the x-axis? Every grid line is 20 tickets sold. This is 40, right? This is 80. Okay. So we need to go to 150. So would that be this one?
No.
No, it's going to be
In between.
right in between 140 and that one. So I want you with your pencil to take that, go where x is equal to 150, and I want you to follow it up and let's see if they made a good choice here. So follow it up to the trend line. This is how you'll convince me that how you got your prediction when you have to do your own. And then you'll carry it over to the vertical axis and say they said that the corresponding y value was 750. Do you agree?
Yes.
Can they make a good prediction from that? Okay. So it's $750 worth of concession sales when if they sell 150 tickets. It's just a prediction. Okay, now they want you to do one. Based on the data, what do you think is a reasonable prediction of how much money will be collected when 90 tickets have been sold? So go find 90 on the x-axis and follow it up to the trend line and follow it straight across to the y-axis and predict the sales for 90 tickets. What is it? What do you think it is, Ashton? What do you predict? 450, because what's every grid line on the y-axis representing? 100. So it's between 400 and 500, so I'm thinking that $450 would be a reasonable prediction for 90 tickets sold. Can we predict going the opposite direction? What if this movie theater said, I wonder how many tickets we'd have to sell to take in about $800 for the concession sales? What would they do then? They want to take in $800 worth of concession sales. What would they do from this data set?
Just go over 800.
They go to 800 on the
Yeah.
y-axis.
180.
So they need to go here on the y-axis, follow it over to the trend line,
And then go down.
and then follow it down and
And
say,
get 180.
and what would it be? I didn't go down, I kind of got off track here, didn't I? Okay, so we go down to here and say 180?
60.
I think it looks more like 160, doesn't it?
180.
Yeah, if they wanted $800 in concession sales, they would say, oh, we sold 160 tickets, it might be safe that we would take in that much money. Okay, so we can use it to predict the x value or the y value. It doesn't have to be always just the y value. It can sometimes be the x value also. Okay, any questions? Okay, then